Let us solve one more problem on Newton-Raphson method. The problem is, show that a root of this equation lies between 1 and 2. That means we need to prove the functional value at this and at this, that is f of 1 and f of 2 have opposite signs. That shows that the root lies between 1 and 2. Then they are asking us to find the root by Newton-Raphson method. So first we need to prove x naught lies between 1 and 2. Then we need to improve our x naught by Newton-Raphson iterative formula. So we have considered the given equation as f of x. Now let us put in the place of x everywhere here 1 and check the sign. Here f of 1 is minus 5, which is negative. Now let us see what is the f of 2 now. F of 2 is 7, which is positive. So we can conclude that the root lies between 1 and 2 because f of 1 is negative and f of 2 is positive. So this completes the first sub question of the problem. Now what should be our x naught? Why we are taking x naught as 1? Because the f of 1, that is minus 5, is very near to 0 than f of 2 value, that is 7. So minus 5 is very near to 0 on the real axis. So that's why we can take x naught as 1. Now we start with the Newton-Raphson formula. In the formula we require f of x as well as f dash of x. How do we find f dash of x? Yes, derivative of f is f dash. Differentiation of x cube is 3x square. Differentiation of 5x will be 5. And differentiation of 11 is 0, which we have not considered. This is the first iteration to find x1. Put the x naught value, which is we have taken it as 1 in this place. F of x naught, that is f of 1 we need to put here, and f dash of 1 we need to find and put in this place. So here we have put x in the place of x naught as 1 everywhere in the formula, and we have simplified here by putting x naught as 1. If you simplify, your final answer will be 1.625. Similarly, now let us use this x1 value to find the value of x2. How do you write the formula for x2? Just replace in this formula x1 by x2 and x0 by x1. Yes, we have written the formula by replacing to get second iteration, and we have put in the place of x1 1.625. Now in the function here, in the place of x you put 1.625, and in f dash also you put in the place of x 1.625, and simplify, you'll get the answer as 1.5154 for the value of x2. And we can improve this x2 again to x3. How? Just by replacing x2 by x3 and x1 by x2 in the formula, we get x3 as this. Now replace x2 value from the previous iteration here and simplify. See, this is our f of x which we have put here, and f dash we have used in the denominator here as per the formula, and simplify using scientific calculator, you will get this. So we have done 3 iterations, that is sufficient for, and hence the required answer is 1.5106. Next problem on Newton-Raphson method. Find a real root of the equation. So here is a given equation. By applying Newton-Raphson method, they are asking us to carry out two iterations. That is, we need to find x1 and x2. First step is take f of x as this. Now next what is the next step? We need to find the interval where the root lies. How do we find? We go on giving the values for x till we get two consecutive values for which the functional sign is opposite. So let us start with x is equal to 0. X is equal to 0 gives us the positive value. Now let us go for one more value of x. We need to get negative value. So can we take the next value as 1 or 2, 3, 4? No, we cannot take these positive values because here all the signs in between are all plus. If you take positive integers, you will never get a negative answer here. You will never get a negative answer for positive integers because all are plus. So better we go for negative values of x. So we have taken x is equal to -1, for which we got +1, which is again positive. Now let us take -2 next. If you take -2 in the place of x, see here you got -6, which is negative. So which are the consecutive values? -1 is one value for which it is positive, and then -2 is another value for which functional value is negative, that is opposite sign. So we can conclude that our root lies between -1 and -2. And we take x naught as -1 because this 1 is very near to 0 than -6. So we take x naught as -1, and we start with the iteration of Newton-Raphson method. For that we require f dash of x. So differentiate f of x. Differentiation of x cube is 3x square. Differentiation of x square is 2x. Differentiation of 3x is 3. And differentiation of 4 is 0, which we have not mentioned. So go for first iteration, that is x1. Substitute the value of x naught as -1 everywhere in the formula in f of x naught and f dash of x naught everywhere. We get the answer as -1.25. Then we find x2 because they are asking us to carry out two iterations. So when you substitute the value of x1 in this formula and simplify, you will get the answer as -1.2229. You can conclude the result as -1.223. That is, we have corrected up to 3 decimal places. We have corrected here. Since this number is greater than 5, we have given the increment to this number by 1. So this completes one more problem.